Okay. Oh, because it needs to be a string. Uh, um, That would be 0144 4041. 4041. Let me do a solid. Right. Wait a minute. Yeah, no, yeah. And then main window.screen.lit. NPC bar, and then we will want tube two and okay. Let's try it out. Tuple object does not support items. Then how about we just give it a random number then? Worry about, oh, it might ask for object creation object is not scriptable. Oh, okay, I get it. Yep. So NPC bar pause equal bar. No, so that we take the bar pause. That should fix that, right? Still no? Hold on. Oh wait, because we're not using subscripts on this. It's dot position. Okay. Yeah. Dot position. Course. Oh, and then dot image. Argument 1 must be Pygame.service, not none. I thought that when we did this, or do we? Is it the fact that I'm using the data class structure and I'm not just initializing all that? Yeah, that's what it really should be, shouldn't it? So let's just take all this shit. Let's remove data class. So we need and Shit, did I forget how to do classes? Fuck. Eh. Name and a colon, so... Okay, yes. Okay. I need to put this all in under the initialize. Let's just take all that extra. Plop it right there, huh? Go ahead. Okay. Now we do self dot. Okay. When we initialize it, oh shit. Oops. And then you know what? We're not even gonna use position. You know what's crazy is I can't believe I just absolutely crazy. Alright. Oh shit, they're down there. Can we make like 40 of those or something? Damn. Okay. Oh, are they all on the same? This is why you don't do it here. This is why we didn't. That's a reasonable amount of characters, yeah. Be in a range. Okay. Now. Okay, so. Now. Okay, how we get to let's do that. Let's do go down here. Finished all of that. All of it. Okay, so now I got control. Uh, the OBS, do we do game capture for that instead? Okay. What we have to do. Now we're just gonna pull this. And now. Oh. Oops. So every object has its position, which is this right here, and then we draw the image box around at a fixed point. So if this right here is the original position, and this is where we put the image. But now we have X in the minus and Y in the positive in this quadrant. We have X in the plus and Y in the plus in this quadrant. Then we have X minus and Y minus, and we have X plus Y minus. Okay, so we need to detect when an object is in this area about to collide with the object, right? So how do we get there? So we need to do 4 different checks. Well, first, we should see if the absolute values, so the absolute values of all these, the difference between the character and, so for -20, -20. Oh, and then right. So we have people that are 0, 0, so that's this person. We have -20, -20, which would be, so if we do 20 by 20 images, right, and we do -10 for the center, so that's 10 pixels out in either direction that they are. So if we had someone at 20, 20, so if this is 10, we add another 10, this, oh shit, that should be the edge of their box, right? So the edge of their box is 2020. Oh no. That's their position. So that this is their box then. So if they're that far out, they are about 5 pixels away from colliding, or 10 pixels away from colliding, right? Because if you had somebody who was -10, is that and 10. Oh, I did that wrong. That's -20, 20. So if we had -10, 10, that's about right here. So then their box collides with everybody else's. So 0, 0 is not with them, and -20, 20 isn't with them, but -10, 10 is within both of them. So it doesn't matter whether or not the player, or it doesn't matter if the NPCs collide right now. We're not actually detecting that. We're detecting whether or not I do not know how to do C++. So let's go ahead and go back to the code real quick. Because I want to do the collision detection. So for item in world edit dot world characters, we are now going to examine the random 6 people that we create, the red and the blue, because not only are we going to do collision detection. I'm doing good, man. How are you? Man or woman, you know, I just say man because that's who I am. Or, you know, you could be a fucking tree for all I care, you know what I mean? As long as you're... How's life? Man, do I, hello? Who are you? Hello, how are you? I'm doing alright. Doing okay. Every day we overcome our barriers. Every day we overcome our obstacles. But are you able to do that? You know what I mean? So back to this. So we have X and Y for item position. That's the character position. So now we need to check if X is greater than the absolute difference of player dot world X coordinate minus X. Wait, right? No. Okay, so if X, okay, no, okay. Wait, no, we want the absolute, right? We want the absolute. So we want this to be greater than 10, right? Greater than 10. And then we'll want to do the same thing for Y. So I'm gonna select all that. What built in for that? Is it just args? No. I used it before, didn't I? No, I did. It should be next in the iteration, right? Hold on. I'm gonna look that up real quick. I'm just gonna look that up just real quick, right? Because it's like, uh, it's on next. Okay, so next iterators operates on iterators which objects and produce in a sequence of each retrieving the next item. So we need to each call to next iterator returns the next value in a sequence. Okay, so my list, my iterator, my list, for item in my iterator. Next item equals next iterator. Often used with generators where you might want to extract a value outside the loop's norm. Okay, so it's used for extraction, not skipping. Skip for loop. Oh, continue. Okay. Skip an iteration of a for loop. Skip even numbers. Got it. Okay. Finally, I knew there was something there for it. I knew it. Absolutely knew it. So we need to do continue. Else. Run this. Yep, collision detected. Oh yeah, see, that's perfect. That is perfect. That is perfect. It actually works. It actually works. So this is great. This is awesome. We're already doing object collision detection, which is phenomenal. So now that we have that, we probably need to run a function. Let's write pass for now. Let's just write pass for now because we want this. Let's just minimize. Let's just go back to basics. We need a function outside of a class where we determine which direction the player should move, right? Or we can have it change something here. So class player object, and we will do is player lighting, right, equals false, right? So then we go down here to where we are doing this at. So if it isn't, it's going to continue. If it is, it's going to break the loop first. Because, or not first, well, yes, we could do first actually. So we're going to break out of the loop, and then we're going to set the player variable, right, wait, player variable dot is for player colliding true, right? Okay, player variable is player colliding is equal to true, and then we can add and player var dot is player colliding, or and not. That's what we want, and not. So we want to add that batch right here. So when we launch this and we go up, oh nope, nope, okay, okay, wait. Problem here. Why won't that? Because it proved to me that. Huh. Huh. Wait, hold on. What? Why is it doing that? Why would it be doing that? Wonder. So, is it because we break out of the loop? It is. Oh my god, I'm so stupid. So stupid. You can't break first. Expecting it to still run the code. It's in the for loop, you dipshit. Fuck. Okay. And before this, we're gonna do player variable dot is player colliding false, and then we're gonna. Now it should work, right? So we're gonna run all the way up here. It shouldn't. Yeah. See, so if we get anywhere near them, although that is quite the gap actually. Greater than 10. Let's do 5. Let's cut that in half and see how close we get, because we want. Okay, that's actually way better. And then depending on the. Okay, so depending on the exact direction, like the difference, right? So if the difference, this will just go back to this diagram I had. So if the difference, so we have it set up so it detects collision. Now we need to find out which direction it's going. So the difference between the player and the NPC positions, right? We want it to, if the player X is less than, right, less than the NPCs and the Y is greater than the NPC, then we will decrease X and increase Y. So each of these quadrants are basically like, okay, do these checks now. Well, that might mean we might want to do this. So well, actually, you know what? Do this. If wait, what? Oh, else. Okay, yeah. Okay, so it will, if for each item in the list of characters, it will go to this line. If it is unable to go through this line and pass through it without continuing to the next item, it will do this. And then if player variable dot is player colliding this, and then if player variable that's where we put the break, because npx and npy, right? Wait, no, we already have x and y, so we need py px equals player variable dot position. No, player variable dot world x coordinate. Oh, okay, we're back. That was Yeah, yeah, it did. It did. It really messed it up again. And I'm sitting here talking about this shit. Just sitting here talking about it, and it's not even coming out. So I think because of this initial if else statement, I think I just need to turn this into a elif, and then this little statement here, right? Needs to be 5 is greater, and right, we just need that, I think, because it should only detect when you're right there. Oh, okay, I'm technically within the bounds of it. So now that we changed it again, I believe we can put the equal signs back inside these operators. Oh my. I believe now that we did that, we could put the equal signs back into the operator. Because we want it to move no matter what, right? Like hello. Is 5 not a big enough number? I think now, because we changed everything. Yeah, now that we changed everything back, that we can do it. Okay, so let's change that back from 5. Where is it? It's in the place we were just looking at. Okay, so this 5 be 8 n maybe. No. Yeah. No, wait. Yes, they should be the same number. This is the distance between the objects, so they need at least n, because the length of the image. See? Okay, cool. So we now have collision detection on our objects. This is great. Oh my god, okay, yes. Now, even further than that, let's do another 3 pixels each, I think. Or no, yes, that will do the trick, I think. Oh man, it feels good to make a little bit of progress. A little bit of progress goes a long way, and I hope anybody that's listening is enjoying this too. So let's go ahead and test what it looks like under that. What if there's 2 objects? I can almost go in between them. I got stuck. You know what? Oh, you know why I'm stuck is because I am in between 2 objects. Okay. Okay, I did not think about getting propped in between 2 objects. So how would you solve this issue, right? So if you're stuck between 2 objects, let me just show this real quick. Let me just show this. So if you are stuck between 2 objects, so does that mean that, wow, okay, so it does this for everything, right? So it will determine if, so okay, cool. Now I know. I think I know how to fix this. Is player stuck equals false, right? So if is player stuck is false, and they are still colliding after detection. So okay, no, we can't have that inside the loop. So we can't have it inside the loop. So here's what we're gonna do real quick. We're gonna go up here and we're gonna go under our character. We're gonna go under player object. So now we're gonna do is player stuck equals false, right? So for the item in world edit, we want to do this. We want to do collision count equals 0, right? We're going to make collision count equals 0 at the start of every detection. So now it's going to run through every item. And if it's colliding, right, we're going to say it's true, and we're going to increment collision count by 1, right? Now, if it's going through here, and it's determining whether or not you're colliding, right? Underneath this, we're just gonna have it here. If collision count is greater than or equal, or greater than 1, player variable dot is player stuck equals true, right? Then elif player variable dot is player stuck move player Ooh, man, I almost want to create a list, right? I almost want to create a list of objects, so to speak. It's object-oriented programming, right? So the idea is that we make a list, and the list is of detections. So the length of the list is the count, technically, right? So we then put inside the positions of them, right? And then we try to find one that is even greater than that, you know what I mean? So maybe we have to add even more, right? So need to find. Let me draw this out. Let me visualize that. I think that's what'll actually help, right? Is if I visualize this. So if I go to this, right, and then I take this little image right here, and we have this guy, and this is me, right? So if this was on my game, I would be damn near colliding, because if they were all the same size, they would all be scrunched together. So if I'm colliding, right, there's 2 collisions. Now, I definitely need to do that. So there we go. Okay, cool. Now collision count dot append, right? And then we do X and Y. Right. Okay, cool. Now we need to take no, this is actually where like trigonometry comes into play, because we have a triangle of distances, right? And we want to know what is the distance between me and him, and what is the distance between me and him. Then we need to figure out if the distance between me and him is positive or negative in both the X and Y axis. So this is actually an even greater check of collisions, right? Because now we need to verify what is actually in the way, so to speak. So now that there's multiple detections, this is no longer single detection, this is multi-detection. So now we have to run a little bit of math on this. And I really have to use the bathroom. So meantime, enjoy the screen. I'll be right back. Now that we have an idea here, we need to put it into our thing, our code, right? So now that we're doing multi-collision, so collision count, it appends it to the list, and if the list is greater than 1, the player will be stuck. Now, if the player is stuck, we need to move the player, but we don't need. Okay, so first we need to think. We need to think here, because I'm not a mathematician. I don't know anybody who is a mathematician. This isn't my strong suit. So, what would be the best course of action here? So we need to take the difference between me and him, and him and him, and me and him. Okay, so, and then we create a vector off that, right? So I'm trying to think how to do that, right? I've never done it, so I have to come up with a solution right now. Let's think here. Trial and error is the only way to get through this if I don't know how to do it, and I'm not gonna just look it up, right? So let's see here. We want to actually create a new function. Move player dynamic. See, right? Oh, that's dynamically, right? That's how you. Is it 2 Y's or 1? Definitely 2, right? Dynamically, dynamical. Right, let's just do dynamic. That's such a hard language. So we come up here to move player. Now we want to def move player dynamic. So now I need to do expy x. Well, actually, list of x's really. So list of collision. Right. So we have player x, player y, list of collisions, which actually we only need list of collisions. So we will take move player dynamic, we will put collision count in there. And now we can work. Now we can work up here outside of the confines of that grouping down there of code, so that, you know, maybe it'll be easier for us to come to the solution if we give it its own space to figure it out, right? So we're using the function just like we're using move player, but we're gonna run our checks that we did down here up there instead, because I feel like this entire block right here is our normal collision detection. We will not need to go outside of this block unless collision count is greater than 1. So, and to be fair, is that under is colliding? Yes, it is. So it's fine. That's fine. This whole block only triggers if player is colliding. So then, as soon as it knows it's colliding, it's gonna see if it's colliding with more than one person, and then if it's colliding with more than one person, it's going to move from the normal player move to the dynamic move, because we actually need to figure it out what direction we want to move, because, you know, I can't be asked to do whatever. So for item in list of collisions, we need to how do we prepare for potentially more than one direction? So I'm thinking, right, that we almost add up the direction it should go. So for item in list of collisions, we want to compare it to all the others. So I don't believe we should have more than one collision, but if that's the case, then we need to actually start total x, total y. Is this back to the drawing board for visualization? I think it is. I really do. I really think it is. So let's do some numbers here. So if we have got, I'm gonna do something real quick for this music, since it's kind of my older stuff. So I'm just gonna go back to the start. Things were a little bit more professional. That old stuff just sounds horrible. As if that's any better, but you know how it is. You know how it is. So we want to actually show you guys the visualization, because I wanna do some potential math here, right? So the only way we're gonna do this is if we run numbers, right? So if we're at 0, 0, that is us. We are at 0, 0. There is somebody within our detection box, so that's gonna be within, what is it, 10? It could be 10, or sorry, negative 10, because we work with absolutes. Negative 10, fucking 3, right? We got negative 10, 3 here. And then over here, we've got negative 10, fucking, I don't know. Technically, both of these guys are within our detection range, right? So the question is, what kind of math is required to make a difference here. So we're in the detection, so it's going to budge us 5 in the opposite direction, hopefully, of both of them. So that might mean something completely different. A terrible example. If this is -10, what would that be? That'd have to be +10, right? So if this is +10, -5. This is just an example. Okay, so I know this is completely botched, but if you have -10, 10, 0, 0, and 10, -5, so that means you've got someone in the top left of you and someone, or sorry, in the bottom left, right? -10 plus 10. No, okay, -10 plus 10, that's the top left. So you have someone at the top left of you, and you have someone in the bottom right. Very slight bottom right. Now you need to find out how you can bounce away from this guy and this guy. So what it looks like is we're gonna have to run absolutes again. Absolutes, because if someone is to your left and someone is to your right, we're gonna have to make you go up or down, right? Now, I'm not entirely sure how to get somebody to move either up or down depending on this. This is a formula, obviously. So we need to take each of the x's, right? So we need to take all the x's, -10 and 10 of all the collisions. It could be more, it could be 5, it could be 7, it could be 8, you know. And then we need to take the y's, so that would be 10, that would be -5, that would be 5, that would be 7, that would be 8, right? So we need to take these. Take these, we'll put them up here. Put them up here. Put them up here. Now with those, we need to figure out which direction we're gonna go. So, are we gonna run some statistics, I wonder? Let me think here. So if we took absolute values, we don't want absolute values. We want to compare their x to our x. So basically, it's gonna happen like this. If ex is 0, right, and npx is -10, or in other words, npx is, or sorry, ex is greater than npx. That means the x axis is to the left, right? So that's gonna be basically the first rule that we focus on here, is which direction are they coming from? Because we basically have to do some arithmetic here based off of these calculations. So let me just actually take this off, right? Let's do this. And then let's do this. Let's do. So if p of x is greater than that, the x-axis would be right. then we'll go down to this and we will change this to p of y is that. Do this. So if the player is greater than that, and then, oops. Okay, so these are our rules, right? These are the rules, and now basically what we want to do is we want to take all of these directions. So left, wasn't there an easier way to edit the text here? This one, there was a box for it. Damn, I can't. Fine. So then we take left, right, and then up and down. And this is gonna make sense in a second when I actually get the stuff typed up, because it honestly, if I wasn't using a drawing program to visualize the stuff, it would have been easier to type this out in text, but I do want to do this. So we have 2 detections, right? 2 detections, that's all we have. But what does that mean for us? It means that we need to see, so this guy is a lesser x and a greater y. So he is left. Oh shit, I need to go to the paint layer. He is on the left and up. And then this guy, he's on the right and the down. So that's the tough part, is for each of these we have to do a weight value. So now we have a count. Now we have a physical count of where they are. There's one left and up, and there's one right and down. So what is the best course of action? Well, now we have to compare the distance. So not only are we going to tally left, right, up, and down, or I guess each count would make sense, right? So if it's left and up, if it's right and up, if it's left, if it's up, if it's right, if it's down. So we have to do a comparison for, is it left and up? Is it left and down? Is it right and up? Is it right and down? Is it left and equal up and down? Or is it down and equal left and right? You know, so we now have to do a comparison for each of these steps. So this is why I had to completely section it off from the other collision detection entirely, because this is going to be a major block of code. This is actually probably going to be the blockiest block of code for this for what we have so far. Very basic, right? So let's see here. I want to take the source. I want to take that off, and now that we have an idea of where we're going, we need to do this. Okay, if e of x, which, oh wait, no, now we need to do this. So now we need to take e of x p of y. We do need to take it. I forgot we do need to declare these variables. So go back down here to this, and then we're gonna do, I believe we haven't quite declared ex and py, so perhaps we do that up here before we check it with everything. All right, cool. Cool. I guess if that's the case, we can actually do this px and then take this y dy. Okay, so that still works, correct? Probably. Let's go back up here. Let's do if you, just so I can launch it here, right? So it still works, still here. Collision detection still works, right? But multi-collision detection is the problem. So I'm gonna change that up here right now. If I have the energy for it. I have been doing an hour and a half, 2 hours almost on multi collision detection to collision detection, and in fact just general framework while taking notes the whole time, basically. So putting in some work today, even if it doesn't matter, right? So if true, we don't want that. If e of x is greater than item, well, actually, shit here. For each item, we will actually just want to do npx and npy are equal to item 0, and because I hate typing the brackets and the numbers instead of just using the variables. So if it's greater than npx and ey greater than, to pass, I need to do 4 of these and then 8. I believe that's it, right? Any Audi left and right. Yes, that's all 4. So that's the specific quadrants, right? Now, do we do the equals as well? That's 12. That's 12 if statements each, right? At that point, these should be elifs. Just because we want to run it on the same line instead of adding a new line to it. Hope everyone's enjoying watching or listening. I didn't realize we had some people in here. How's everyone doing? P of x, P of y, if greater than, yes. Okay. So, now, wait, do we do left count, right, up count, down count? Is that how we want to do this? I wonder if that's how we want to do it. Yeah. I think it's worth it. So Yeah, because if it's both greater than, right, then we should increase. Okay, so if x is greater and y is greater, then up or left and down. Let's see. 1 up. Oh, let's see. Or no, that's the opposite because the p of x is greater, right? So if the player is to the left and up, then they are to the right and down. I know I did that backwards, but it's fine. Fine. This is based off the player, right? So we might as well be in the perspective of the player. So if this is then left count plus equals 1 and down count plus equals 1 and that's right count plus equals 1 and plus equals 1. This is left count plus equals 1. Down, up count. Okay, cool. So now we do the 8 other ones, right? Let me copy this section. Ugh. Now, if greater than okay, cool. Now, we move life in twos, so I wonder if... No. Okay, we gotta do some equals too here, right? Yeah, because this is just x, and it's not y, and then we'll do the same for y, right? So that's this bit here, and then we'll do this bit here. Could have did those together, but I didn't. I'm not consistent whatsoever with how I do it, as long as I do it right. Correct? I think so. Hello, everybody. Hello. Welcome to a bunch of if statements, because that's how we live life, is by operators. So if the x is greater, then we just do right count plus equals 1. So I'm just gonna do that. So this is... Oh wait, what am I doing? I don't need 2 of these. I don't need 4 of the same operators. What am I doing, man? Okay. Man, I'm so stupid. I just need the 4. Right? So this is just left count. This is just they would be above us. So this is up count, and then this is down count. Okay, cool. I think we're good on that. So now the numbers should be good. So if I simulated two people to be within the same vicinity, so if I did like 20, 20 to 40, and then 20 to 40, what would that look like? Okay, technically, yes, that is it. Okay. Oh, missing. Oh shit, okay. Crazy, I forgot to add that. Layer dynamic, so we got effects. And it's gonna be like, oh, it's just outer scope or something like that, blah, 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 blah. Oh shit. Yeah, okay, yeah, no. Yeah, see, outer scope. Show quick fixes, rename the element. X, X, Y, Y, X, X, Y, Y, boom, fixed it. Not from the outer scope. P of X and P of Y. See, that one I don't mind. Because if it's from the outer scope, it's most likely going to be the same thing. So for consistency's sake, whatever. Now, I can't believe. Okay, here. How about we move them a little bit closer? How about we do that? Let's do 200. And 240. How's that? Yeah, that's way closer, right? Yeah, I mean, close enough. Close enough that we can just come over here and we should have multi-collision detection, but it's actually not bad. It's just getting in between two people at an equidistant. So this is really just a matter of trying. Man, you know what sucks? Is it's such a specific situation. It's such a specific situation. Like I almost want to increase it, man. Like, okay, do I even need dynamic collision detection if it's a little bit more broad? Like, 13, was 13 even like a big enough option? Like, was 15 better? You know? Like, I can go and run at this guy and look at that. Wait, okay. I think I need fixed point. Okay, fixed point. Let's do this. We don't want random. We want. Well, we kind of do want random. So let's make. Let's make two people equidistant from each other. So we go with we're about half, so it's about 1280. So it's about 640. So let's do 640. Instead of 360, let's do 300. And then we'll do 660, 300. You know, it's two people in the same plane of existence, right? Oh, there's no comma. Oh, I need an extra guy there. Guy there. Not fixed. Okay, that's not far enough apart. Let's do 610. That might be good enough. Whoa. Okay, it's not even affecting this guy, even though he's an object. So if I came in, not being detected. This guy is. So that's just weird, right? I don't think no. People closer together over here. I wonder what that'll look like. Can I get stuck? Hold on, I might not even need this collision detection. Really? Wow. Okay, it's whatever to me at this point. You know how it is. We're out here. We're getting froggy. We're doing whatever. I just don't understand why that last person isn't colliding. Because they're real. They're clearly real. Is it because like they're not like 1 pixel to the north or something? Let me see. No, it just doesn't even acknowledge their existence. Oh, oh wait. Oh. So if I approach... Man, what? This guy's not, except for right here. The only place he collides, he doesn't collide with the north at all. In fact, it's only right here. There's a little dot that it collides with right here. So I'm confused. It's okay. I know what it is. I know what it is. It's not even a problem with dynamics. So I just wasted my whole time making a dynamic collision when it's because we're using absolutes. So hold on. Let me think here. When the collision is detected, it should only have to take care of one collision at a time. And so let's see. Go back down here. So if the absolutes are doing it. Let's see here. If oh, you know what it is. I think I have some of these mixed up actually. I think I've messed up. I do think I messed up. It's the only plausible answer, right? I think I messed up here specifically because if the x is greater than or equal to, maybe I messed up entirely with this, right? So let's do this. Take away the stuck, right? Let's take away the stuck. We don't need stuck. We don't need collision counts. We don't need all that. We need better collision detection. That's all it is. All it is. Because it does it for every character, regardless. So we need it for if x is greater than and y is greater than, right? So if the x, okay, this is quadrants. This is clearly quadrants, right? So that's where we move them at. So if we're going to change this, let's do it this way. Add them in between, maybe. So if the player is above to the right, if the player is above them, wait, no, that's left and right. So if the player is to the left, it moves to the left. And then if the player is above them, it should also subtract. And then this is the one that should add. I think that's what's wrong with it, right? Oh shit, right? The hell? Those bad examples. Maybe. Okay, so I came in from the top. Perhaps we need to evaluate this. Look, I just went inside the motherfucker. So where's this box that the oh my god. So when I assign them this box, right? I assign them their position, their collision box different. I feel like I did minus, but I need to do plus. No, because the center of the circle should be the box, right? So that means we have to place the image 10 by 10 away from it so that the center of the position becomes the center of the image. If that makes any sense. I know it doesn't. In fact, I might need a break from this. Like, holy shit. I've been working on this for hours. I think I made a lot of progress. So yeah, thanks everyone for joining. Really had fun. Everyone was super quiet, you know. y'all got anything to say, you know, just go ahead, get it out, throw it out there. I think I'm done, you know. Guess we could leave the I think we're gonna switch gears. Holy shit. Fucking exhausted. Been working all day too, exercising my mind, my body, my soul. I hope everyone else is too, you know. Hope everybody out there is enjoying themselves. Thinking about positive change, creation over destruction, avoiding manipulation as much as possible. Obviously, if you want to change a negative aspect into a positive one, you have to manipulate it, right? It's all about how you look at it, how you approach it, and what kind of emotions are tied to it. And how extreme your measures are, you know, how far you have to take things. So if you have an eating problem, stay away from food. Don't think about food. Every time you think about food, you gotta put some sort of negative affliction on that, right? Just to counteract the false positive that you created. So if you're sitting there, oh yeah, food's good, food's nourishment, right? Too much food, that's gluttony, right? So yeah, keep on tooting, keep on moving, keep on promoting that positive aspects. Or positive reflections is what you should really call them. Have positive reflections.